Okay, we're going to be looking at standard deviation calculations in this video. So let's go ahead and get started. Let's say we have the average length of stay for several patients at a hospital, and those are going to be as follows. So we have 0, 0, 1, 1, 2, 5, and 7. Okay, so we have this length of stay here. We want to find the standard deviation of these data values. When I'm finding the standard deviation, the very first question I need to ask myself is, am I looking at a sample or am I looking at a population? Now, this is important to note because there are two different formulas for both of these. So in a sample, this is given to us as a sample. Our denominator is going to be different, and we're going to do a video for both of these, so make sure you watch both. So this is actually a sample because it's only 7 data values. Okay, this is not the entire population of the hospital. So we're going to use the sample formula, which is going to be given to us like so. So you have S for sample, and it is important to note here that we're using an English letter S. So we use English letters when we're doing samples, and we're going to use Greek lettering for populations. And when we do technology, you'll see the difference on those. So for the formula, we're going to do the sum of x minus x bar squared over n minus 1, and then we're going to take the square root of the whole thing. Okay, so to do that, what we want to do is we're going to create columns. That's going to be the easiest way to do this by hand. So we have our length of stay. What we want to do next is we want to do x minus x bar. Now, x is going to be this data right here. X bar is going to be the mean. So we do want to go ahead and calculate that mean real quick. So let's go ahead and add these together. So that gives us 16, and we have 7 data values. So we're going to do 1 decimal place. That mean is going to be 2.3. So I'm just going to note over here, x bar 2.3. So now what we're going to do is x minus x bar. So here we're going to do 0 minus 2.3, which is going to give us a negative 2.3. Same thing right here. Then we're going to do 1 minus 2.3. It'll give us a negative 1.3. Same thing right here. Then 2 minus 2.3 will give us a negative 0.3. Then we have 5 minus 2.3 will give us 2.7. And then 7 minus 2.3 will give us 4.7. Okay, so we have x minus x bar. Then what we want to do is we want to square these. Okay, so we're going to take these x bars and we're going to square those. Okay, now it is important to note that when I'm looking at this, I want to do the squaring first before I do the sum, because remember, in order of operations, exponents will come before addition. So I want to do the exponent first. So I'm going to do x minus x bar squared. So that means I'm squaring each of these values. So I have negative 2.3 squared, which is just negative 2.3 times negative 2.3, and that should actually be positive because I did not put it in parentheses, because a negative times a negative is a positive. So 5.29 for these first 2 columns here. Then negative 1.3 squared. So 1.69. Then negative 0.3 squared. So 0.09. 2.7 squared. 7.29. 4.7 squared. 22.09. And now I want to find the sum of this column. So that will be the numerator in this calculation here. So the sum of this column here, we'll go ahead and add those together. And that's going to give us 43.43. So the sum of x minus x bar squared is going to be 43.43. So I'm just going to start typing this in here. So I have 43.43. I want to divide that by n minus 1. So that's going to be the total number of values here. So there's 7 values. So I have 7 minus 1. That's going to give me 6. So I'm going to go ahead and do that calculation. 43.43 divided by 6. And then I'm going to take the square root of that value. So square root of 7.23833333. And that's going to give me 2.6904. So let's go ahead and we'll do 3 decimal places here. So my standard deviation of my sample is 2.690. Now, let's say we want to go ahead and do the population standard deviation. So let's just say this was the length of stay for all patients seen in the last week. We'll just say that's the example here. What changes in this formula now? So let me change colors here. So now we're going to look at a population. The only thing that changes in this formula is the denominator right here and the symbol we use. So this denominator will become n, and this symbol is the Greek letter sigma. So Greek letter sigma here. So all that changes is the denominator. So everything that I did here is still the same. So you're still going to do x minus x bar. Then you're going to square those values and find the sum. You're just going to divide by the entire population, not n minus 1. So I divide by 7 instead of 6 here. So if I want to find the population standard deviation, I'm going to do 43.43 divided by 7. Then I'm going to take the square root of that number. And that's going to give me 2.491. So notice that these numbers are fairly different, okay? And the larger your data gets, the more different that they will be. So you really want to make sure you're asking yourself in the initial part of the question, am I doing a sample or am I doing a population? Remember, a sample is a subset of the population. So in a group of 7 patients, in a group of 5 employees, examples like that. Population, all employees of a company or every patient seen. So look for the words all or every for population. So very, very important that you ask yourself that question first. Then you can go ahead and compute the calculation for standard deviation for either one of these.